Good afternoon, everybody. Today we're going to talk about the 2023 US Open Latin level problem number 1. The problem is like this. So there is a string from Farmer Jones, like for example, like this. And the Farmer Jones wants to find how many Bessie is in there. So they define a function which is P of S, that is the maximum number of repeated copy of Bessie by deleting some characters. Then you can take any consecutive continuous substrings of this original string, and then you get a B, right? Then if you add those B together, you get the function A. The question is, how do we what is the function A? And then subsequently, you could replace the characters in the location, right, with another character, and then what will be the function of A? So let's start from simple, right? Let's say if we have one string, S, how do we calculate this A of T? So for example, if I have, right, Bessie and Bessie, okay. You could have some other characters anywhere you could delete it, and then you have a bunch of other things behind it. So this is your string. You want to find this in one scan from left to right. That's what you want to do. So let's think about this way. You would like to find Bessie, right? You could have, let me copy this string down here. BSSIE. Okay, so you could have two index. One index go from here to here, right? Because every time you find it, you find a match, you move to the next one, right? So another index, you go from here to here. Every time you find a matching, you move forward. If you don't find a match, right? So first you find the B, you move to here. Then you find, oh, E matches, you move to the next one. Then let's say this is something L. This doesn't match because you know the next one you want to find the S. So this moves forward and this does not move. Right? So until you hear this thing reach to the end and you find a match. So then you find one Bessie, right? So then how do you count? Let's say if this index moved here, this index moved here. How do you find what are the substrings? Let's say after this, you still have X characters. So obviously you can take this Bessie and match with any of this character, because it's a continuous substring, right? You can take this as your substring, you can take up to here is a substring, up to here is a substring. So there is total of X of those. Then how many you have in the front? If you take starting from here, you only have one Bessie, right? B is one. But let's say you have a bunch of other here. If you're starting from here, then you have two of them. So if I can have a track, in addition to this, let's say I have two I have two variables. One is related to this index that I show how many I have, right? How many Bessie I have in the front. The other one is up to here, how many total characters I have in the front, which is actually just an index of this, right? So then I could calculate, remember, I could calculate this way. Think about this. If I here have a Bessie, if I here I have another Bessie, when I calculate here, I would theoretically this B of this substring has to be equal to 2, right? But I can count it this way. Let's say up to here, if I only count up in the front, just like this one, right? Just like this one, I have one Betsy times how many characters I have here. But here, then I did not count this, right? So that means at here, I also counted 1 times here, right? So this plus this, I got 2, right? So initially when I do this, it has to be 2. So instead of counting B of S, B for each of those substrings, which you have to take care of what's behind it, I just count everything in the front, and then I just add it up, right? So it has to be this X times this information in the front, right? So that's how I get for one string, I will get that information. So I have two index, and for each index, I count at each location how many Bessie I have found in the front and how many amount of characters I have. So now with this one scan, I can get A of this string. But then they want me to change it, right? How do I do that? So think about it. I have this string now, right? I have my S. For each location, right? As I said, for each location, I have this variable now, right? And I have how many in the front and how many in the back, right? Every time I update it, isn't that just like updating the tree, right? Think about it. When I change it, it actually impacts, right? There's two things. If I change something, which is not in the Betsy, it doesn't impact anything. Right? So if I have B, C, L, S, S, I, if I change L to R, it doesn't change anything. Or if I change this, if I change something from non-Betsy to Betsy, let's say here is another S, and change this to L, it doesn't change. I still have a Betsy, right? But if I change from S to P and it doesn't have an S here, then it changes. So this will move away. So propagate all the way down, right? So this is actually, think about this as a segment tree. And you are doing an update of the segment tree, okay? So exactly how you do this, I leave it up to you. But I'll give you a hint. You need to keep left, right, count, and sum. You need to keep those four for each node, right? Left is, you're starting from the left end of the region, right? Right is from the right end of the region. Count is for all the substrings, and S is, left side, it has to be from left, right side has to be from right, the whole thing. Okay, those counts. then you can merge them together when you go from one node to another node. Okay, so this is you can do this update with uh, um, segment tree propagation and range update. Okay, so that is how you figure this out. It's not super difficult. Two things that you have to figure out is when you how do you do this one scan to figure all the things out instead of calculating BFS, for the end, you just break it up and then you track all those things. Then the second one is once you figure this out, how do you do the update? Which is you do a segment tree update and keep multiple things to track it. I leave you the homework of how to do this segment tree update. It's not difficult. It's very similar to a bunch of range update with coefficients, like we discussed before. Okay, so that is a problem for today. So next week we're going to talk about the next problem, which is not that difficult either, but you have to figure out how to derive the equations, the propagations, the dp propagations. Okay, so good luck for this week and take the time to work out the solutions for the segment tree.